Good morning, everyone. My name's Darren Agnew. I'm an Associate Fire Engineer for Hydrock, responsible for the North West region. I would like to welcome you to the fourth webinar in the series provided by Hydrock's Fire Safety Division. Previous webinars by Fire Safety Division and those provided by other disciplines at Hydrock can be found at hydrock.com/webinars. You should all be aware that we're about to undergo the biggest shake-up in fire safety legislation in the last 45 years. This also includes the golden thread, where it will be the duty of the people accountable for a building to put in place and maintain a digital golden thread of information. Having a golden thread will mean that those people accountable will have easily accessible, reliable, up-to-date and accurate information. Without this information, it will be very difficult to manage buildings safely. This morning, our Director of Fire Safety, Chris Chanel, will be discussing the golden thread of information, the impact it has on a construction project and the wider industry, and the things you should consider as we adapt to this new requirement. Before handing over to Chris, I would like to point out that we will be happy to answer any questions at the end of the webinar. If you could put your name and company, if we don't get to the questions later on, we'll be sure to email you. If you'd like to ask Chris a question, please simply type your question into the chat box. Over to you, Chris.
Brilliant, thank you, Darren. Good morning, everybody. Thank you for joining. Hopefully you can see my screen. Today we're going to be talking about the golden thread. We'll be focusing on the challenges coming after the Grenfell tower disaster and how these will affect the building industry. My name's Chris Chanel and I've recently joined Hydrock in the Fire Safety Division. Kevin asked me during our initial conversations, even before I joined, if I'd like to take a lead on how the company positions itself in response to the Building Safety Bill. Specifically, the role we will play in capturing the golden thread. This is going to be the first of 2 talks on the subject. We're aiming to hold a panel discussion in the new year. So I hope I can keep your attention for the next hour and you find the content useful so that you can join us for round 2. There's going to be a lot of content presented today, much of which will be referred to back and forth, and as the subject matter is quite challenging. However, I will weave between the topics and add in anecdotes here and there to ease understanding. I'll begin with some introductions about Hydrock, our superb fire division, and the work we do. Then we'll move on to the changes coming about within the Building Safety Bill. I'll try and set the scene, where we are, how we got here, and then what's coming down the road. A lot of this talk, the aim of this talk is to help you have a better understanding of the topic of how the golden thread can be captured and operated throughout the life of the building. While reference will be made to BS 8644, this talk does not focus on that guidance document. BS 8644 is expected to provide guidance on the collection of digital data, guidance on what content to be expected in golden thread, and in what format this will need to be presented. As BS 8644 is in public consultation, rather than guess what will be contained, we will focus this talk on who needs to be involved and when to capture the golden thread data. So a little bit about Hydrock. Here's some of our corporate values. As you can see, we're a corporate partner for the UK Green Building Council, and we've been a successive award-winning company for the best place to work. Our core services, as you can see, there's a focus here moving away from the typical structures and MEP focus, more of the high value offerings within the building industry. And some of our specialisms that we're known for, with a keen focus on sustainability and transition over to electric vehicles. We're pretty well spread across the UK, having recently opened a new office in Newcastle and very recently opened a new office in Edinburgh as well. Our main focus of operations is in the southwest, however. So moving on to our fire safety division, set up in 2017. We're now a team of 63, and this picture here is on our recent conference up to Dunblane. We had spent 3 days at the Hydro, and an evening was spent in the Stirling Castle, which is testament to the quality of the team that we have and some of the best fire safety professionals in the world. Our capabilities, new build and existing fire engineering. We have a dedicated team of fire risk managers who are on site doing risk assessment, external wall survey, cavity, door inspections, and some of our more specialist services around nuclear safety case, expert witness. We have an excellent team of structural fire engineers and all of our junior staff are involved in doing research and development, with a lot of our team actively pursuing postgraduate qualifications. Some of the work that we do: Middlewood Locks. This project is a retrospective assessment of the materials used in external walls on pre-existing buildings and fire safety strategy development for the ongoing design risks. Combining our fire engineers and our fire risk managers, we provided full spectrum fire engineering approach to this project. Hunslet Road in Leeds, very dear to my heart. Our contribution stretched from site investigation to transport assessments to energy and sustainability statements. In July, the project was awarded the project winner at the Housing Design Awards. Siemens Train Factory. I often talk to our clients and say we work on everything apart from rail. However, we are delivering a railway factory. This state-of-the-art rail facility will deliver new, lighter, more energy-efficient trains for the Piccadilly line in London Underground. Hangar 86 is the first space in the new 517-acre site to be occupied by Dyson staff. This 100,000 square foot workspace includes a gallery, labs, and testing space. University West of England Engineering Building, we're delivering the state-of-the-art flagship teaching and research building, Hydrock secured planning permission, and is now supporting construction through to completion. Hydrock is providing fire engineering design for the University of Bath Institute of Advanced Automated Propulsion Systems. This new global centre of excellence will deliver transformative research and development for automated propulsion technologies, which will support the development of new generation of low carbon vehicles. Our team is preparing the fire strategy for the building through to the REBA Stage 7. So on to the topic for today. Anyone who surveyed a building, either for a fire risk assessment under the RRO or say during a change of use, will know that the quality and availability of the information is poor, to say the least. As-built plans which are outdated, inaccurate or non-existent, design specifications and strategies which are not handed over, and the operation and maintenance manuals containing information that does not reflect the design intent. Ever since I started as a fire engineering consultant, the disconnect between the design, the build, and the occupation of buildings has been a subject of debate. It has been, until recently, extremely common to be appointed as a fire engineer to solely resolve design problems. Worse still, we sell our professional indemnity insurance to a developer as a fallback. I've been fortunate to have lived and worked in a few countries in my career, and this approach is common across the world. But what does this have to do with the availability of information of existing buildings? Well, let me give you an example. Let's say we have a multi-storey shopping mall. An open void connects all levels, meaning the fire engineer has designed a smoke control system. We're in the UK, so natural smoke vent is feasible, relying on the alarm, cause and effect to detect the fire and actuate the high-level vents and the entrance doors for extract and supply. Sounds pretty straightforward. The design of this space is based upon a series of assumptions. The designer would have designed these assumptions based on the use of the space. Do we have sprinklers? Are sprinklers provided at high level, in the void or beside wall heads? What's the height of the resale units? What width of glazing the panels do we have? Are the resale units used for clothes stores, electric stores, kids' gyms, kitchens with cafes? Will the mall be used for concessions? Will the mall have displays of cars, a Christmas tree, a Santa's Grosso? What's the aerodynamic free area of the specific events? Will their orientation on the roof be affected by adverse wind pressures? How do we protect against this? Are the life safety systems provided with dedicated or diverted secondary power supplies? What delay is set in the fire alarm set for a fire alarm investigation? Will there be a double knock activation strategy? The reason I'm rattling through those systems so quickly is any alteration to any of these systems, and in no way is this an exhaustive list, could mean the smoke control system does not operate as intended, meaning the time people have to escape in the event of fire could be affected. By not having the design specifics readily available throughout the life of the building, end users are not capable to make decisions armed with all the necessary information. One case I heard the other day, similar to this example, was a roof leak in a mall being identified as coming from the seal around an automatic openable vent. The proposed repair was to drill shut the vent, as the space was mechanically conditioned, and no one knew why there were openable vents in the first place. The problem emanates the other way around as well. Designers often introduce complex solutions which the end user has no real appreciation of, or the solution imposes challenges for day-to-day use. Fire curtains across cafe entrances in malls is a prime example. The designer has not considered the needs of the end user. The breakout into the mall to maximise seating numbers, and the operator positioning furniture under the curtain so that it can't drop. So now we know there's a problem. There's a disconnect between what's designed, what is built, and how the building will be occupied. But how does this apply to the Building Safety Bill and high-rise residential buildings? The Grenfell Tower disaster has shone a light on the building industry across the UK and globally. When I was in Melbourne in 2017, the week after Grenfell Tower fire, the federal government instructed all states to implement a programme of building audits of all sleeping risk occupancies that weren't dwellings, and a serving of building notices to owners where combustible material was identified in the external wall. Consequently, the Australian standard 5113 was rolled out, which is based on the BS 8414 test, which you can see here on the screen. Likewise, when I was living in the Middle East, the NFPA 285 test was mandated in the UAE Fire Code and the Saudi Building Code, all for new developments. I'm telling you this so you can appreciate that the impact of this disaster has been felt the world over, as the problem is the same the world over. The Grenfell Tower fire was a disaster due to more than just combustible materials in the facade, however. The inquiry has highlighted that numerous fire doors were held open, or the closing mechanism was redundant. Fire doors have been replaced with non-tested fire doors, therefore not fire doors. Fire compartmentation had been breached with a recent gas main replacement and inadequately fire stopped. The lift did not operate as a firefighter access lift, and the smoke control system in the stair did not maintain the escape route free of smoke. This example illustrates my previous point. If the intended design purpose of a system is not understood and appreciated, how can those who are expected to operate and maintain an adequate level of safety in a building make the right decisions? After the Grenfell Tower fire, a panel of experts led by Dame Judith Hackett was commissioned by the UK government. The aim was to carry out an independent review of building regulations and fire safety, and set up in July 2017. Note, the Grenfell fire happened on the 14th of June 2017. The interim report was published in December 2017 and the final report issued in May 2018, which is pretty rapid when you consider the context. Dame Judith found the current system of building regulations and fire safety is not fit for purpose, and that a culture change is required to support the delivery of buildings that are safe both now and in the future. She made a number of recommendations. However, the one recommendation that we're going to focus on today is the golden thread and this idea of cultural change. So before we move on, a quick summary. Most existing buildings have a poor asset database, meaning during occupation, decisions can be made without an appreciation of the design intent, resulting in occupant safety being potentially compromised. Under the new Building Safety Bill, there will now be an obligation to create a digital record for all high-rise residential buildings. This can be achieved by creating a golden thread of information throughout the design, build, and ongoing throughout the occupation of high-rise residential buildings. Data will be captured during the initial design, through the build, and include any changes that occur throughout occupation. This package of building information will be used by the duty holders to demonstrate to the regulator an adequate level of safety for the building can be maintained throughout its life cycle. A draft Building Safety Bill was published in July 2020, which went before a parliamentary committee in August 2020. Here it was scrutinised by the Housing, Communities and Local Government Select Committee. The revised bill was published in February 21, and the Building Safety Act is anticipated 21-22 to be implemented in 2023. There's an expectation that transition period will take place up to and including 2024. Fundamental to the reforms being proposed by the Building Safety Bill is the way that the design, build and occupation of high-rise residential buildings will be ratified. The Health and Safety Executive has established a building safety regulator in England, headed up by Peter Baker, as Chief Inspector of Buildings. The Building Safety Regulator will have three main functions: overseeing the safety and performance of buildings, helping and encouraging the built environment industry and building control professionals to improve their competence, leading implementation of the new regulatory framework for high-rise residential buildings. The Building Safety Regulator will regulate high-rise buildings, high-rise residential buildings. These are buildings with 7 or more stories and are 18 meters in height and have at least 2 residential units, and it also includes hospitals or care homes only during design and construction. The Building Safety Regulator will have a whole series of other obligations, objectives and responsibilities. However, for this talk, we're solely focusing on high-rise residential buildings. If you've been following the Grenfell inquiry, you'll have seen that most parties being questioned about their involvement in the building refurbishment have attempted to brush off responsibility. This was highlighted by the Hackett report as being endemic in the building industry. The intention of the Building Safety Bill is to address this by ensuring nominated individuals are accountable throughout the life of the building and to ensure their focus is sharpened towards safety. The Building Safety Bill has set out new duty holders throughout the life of a high-rise residential building. These are, during design and build, the client, their principal designer and their principal contractor, and during occupation, the accountable person and their building safety manager. As we're pressed for time, I will focus on the duty holders during occupation only, the accountable person and the building safety manager. The accountable person can be an individual, a partnership, or corporate body. However, there must be a nominated individual so that accountability can be held. The key duty that the accountable person holds under Section 84 of the Building Safety Bill: a requirement to register the building with the Building Safety Regulator. Before occupation, apply for building assurance for a building assurance certificate, which must be displayed, and the building assurance certificate is expected to have the name of the accountable person and the building safety manager listed. Appoint a building safety manager. Assessment of the building safety risks and management of the building safety risks. Create and operate a building safety case and create a building safety case report, which is expected to be every 5 years for submission to the building regulator. And also operates a resident engagement strategy. The focus of this talk is the golden thread. So we will be taking a look at how the accountable person can assess and manage building safety risk. To make the application for the building assurance certificate, it's expected that the accountable person will need to issue the golden thread or the building safety case to the building safety regulator. After they have registered the building with the building safety regulator, the accountable person will need to provide information that as yet is not clearly defined. The Building Safety Bill states the following will be required: prescribed information demonstrating compliance with their duties, a copy of the most recent safety case report, prescribed information about the mandatory occurrence reporting system. None of which is yet provided, which is not surprising as the guidance is still being drafted. However, it does demonstrate that the buck stops with the accountable person for responsibility for registration and for approval by the Building Safety Regulator. So why have I been saying operate and maintain the building safety case? Well, the current regime for building fire safety, implemented by the Regulatory Reform Order in 2005, removed the role of the fire service inspecting buildings periodically and effectively privatised the system so that the responsible person could appoint private fire risk assessors to assess the fire safety in their building. The Grenfell inquiry has highlighted that this system of self-policing safety in buildings engenders a conflict between cost and safety. The Grenfell Health and Safety Manager, during her testimony, repeatedly described how the recommendations of the fire risk assessor would not be addressed for years at a time, even when the London Fire Brigade imposed enforcement orders. The building safety case's principle is to do away with this, purposefully establishing a live system of safety management. The building safety case is intended to replace the annual risk assessment that would often sit in a drawer and be dusted off every 12 months. The accountable person and their building safety manager will be responsible for assessing the building safety risks At regular intervals, at any time the accountable person suspects that the safety case is no longer valid, when a significant change to the building occurs, when the building safety manager notifies the accountable person that they suspect the safety case is no longer valid, or if additional control measures are needed, and at the direction of the building safety regulator. And again, that's expected every 5 years. So fundamental to our understanding of the golden thread is the duty holder tasked with operating and maintaining the building safety case, the building safety manager. The building safety manager role will be multifaceted. Building safety extends much beyond fire safety. Structural safety, gas safety, mechanical, electrical, plumbing safety, Legionella, health and safety will all need to be overseen by the building safety manager. Meaning the role will, certainly in its infancy, be an oversight role, looking after the appointment of experts who will be delivering the safety reviews. The building safety regulator will expect that the building safety case will be operated and maintained by the accountable person, who will then delegate to the building safety manager. Again, operate and maintained, as the building safety case will be a live document that will be continually updated as the building operates. Before we move on to the building safety case, let's touch the topic of competency. One of the recommendations of the Hackett report was that the skills, knowledge, expertise, and behaviours of practitioners in the building industry would need to improve. I'll allow you to read that quote there. And she concludes that there is no doubt at all that competence and accreditation is going to be a major feature in the future. So what's been done about this? Well, there's a new British standard, the Bsi Flex, which is a new system set up with the intention is that it will be responsive to changes in the industry. The Bsi Flex 86 series will provide a set of core principles of competence, including leading and managing safety, communicating safety, delivering safety, risk management, regulations and processes, building systems, ethics, and fire and life safety. The PAS 8670 series has been developed to define skills, knowledge, expertise, and behaviours expected of the principal designers, principal contractors, and building safety managers. Fundamental to the competencies that will be expected on these duty holders are their skills, knowledge, expertise, and behaviours. The building safety manager will be responsible for operating and maintaining the building safety case. Much like all the other guidance, the content expected by the regulator in the safety case is not yet defined. It's likely that, due to the complexity of a safety case, the content will not be prescribed. Rather, the principles upon which a safety case should be based will be defined by the regulator. The Health and Safety Executive have issued guidance on safety case principles for high-rise residential buildings. This document sets out a few key principles for building safety cases. The idea of a major accident hazard, an occurrence that has the potential to adversely impact the health or safety of many people. For example, multiple injuries or deaths, or serious damage to properties. Major accident hazards are resultant from the failure of multiple systems, hence why redundancies within the safety systems, what resilience is inbuilt to prevent failure, and how we can quantitatively measure these against the agreed level of safety will need to be demonstrated in the safety case. A high-rise building major accident hazard will be a fire or structural failure that has the potential to impact the safety of occupants on more than one floor, has the potential to cause harm to occupants across multiple compartments, is one type of event that leads to another, and has an impact on surrounding populations. As is common in residential design, an acceptable level of safety is to contain a fire to the flat of fire origin. The Health and Safety Executive Guidance makes reference to fire and smoke spread beyond the point of origin, which would suggest that a fire event that spreads outside of a flat or compartment would be constituted as a major accident hazard. For high-rise residential buildings, it's proposed that major accident hazards are limited to two broad categories: the spread of fire, structural failure. So the building safety manager will need to be able, or their appointed experts at the very least, to assess structural safety and fire safety. The building safety case will need to identify all fire and structural hazards that could contribute towards a major accident hazard. Much like a performance-based fire engineering design, the building safety case will need to assess all credible fire scenarios that could cause a major accident hazard. Coupled with this is all credible occurrences that could cause structural failure, fire being one, but for example, weatherproofing, water ingress to basements, mechanical damage, penetration protection, concrete cracking, and so on. So the main difference in the new regulator-led regime will be how the building safety manager will quantify the building safety case. The expected major accident hazards will need to be identified, typically in a hazard identification review or HAZID. For residential buildings, this will most certainly include a fire spreading beyond the flat of fire origin. Spread into the common area will be one major accident hazard. Likewise, spread to an adjoining flat would be another major accident hazard. This is where the reasoning to deter from prescribed guidance can be seen. The number of major accident hazards in a building will be subject to any number of variables: building height, a mixture of uses, the location of the plot boundary, the structural design, the number of stairs and lifts, the inclusion of battery storage for photovoltaic panels, and so on and so on. Anyway, I digress. One such approach for quantifying risk could be to undertake a fault analysis. The complexity of the analysis would be defined by the building safety manager or their delegate, subject to the size and shape of the building. One suggested format to adhere to is the following methodology. Fault groups identify fire or structural faults. Undertake a frequency analysis based on fire statistics. Unfortunately, there's lots of statistics around for residential fires. Undertake a consequence analysis. Identify low, medium, or high risk criteria. Designation of safety systems, passive, active, operational safety systems, and set their status, function, and classification. Undertake a sensitivity analysis. Identify single points of failure and how these impact upon the consequence analysis. And identify residual risk reduction, or ALARP, which is what additional measures could be adopted. The expected outcome of this method could be a fire protection schedule handed over to the building safety manager to show what systems are part of the building safety case, an action register resultant from the fault tree analysis, a series of measures to overcome shortfalls in safety, such as training, improving the integrity of passive systems, and upgrading active systems. And concluding the building safety case findings, identifying an overall risk rating to occupants, any residual risk, and a statement on the adequacy of the passive, active, and operational safety measures. So again, to summarize the content we've just been through there, the Building Safety Bill, or the Building Safety Act, is expected to be implemented in 2023. A new series of duty holders with nominated individuals will be accountable for safety. During occupation, the accountable person will need to operate and maintain a building safety case. A level of safety based on preventing and mitigating major accident hazards will need to be quantified by the building safety manager and ratified by the new building safety regulator. But why are we spending so much time focusing on the building safety case when this talk is about the golden thread? Because the golden thread, or rather the capture of data throughout the design and build, will feed into the building safety case. The safety case overrides everything. The golden thread merely forms a part of the holistic safety case. This is where the cultural change will come about. Within current building procurement methods, the ability to identify a single accountable entity throughout the building lifecycle has been resisted as it adds commercial risk for developers and contractors alike. With the introduction of accountable duty holders, at every stage of the life of the building, a nominated individual will be identifiable as being responsible for the safety of that building. Working in collaboration with our esteemed colleagues in the BIM Academy, we have taken a reverse view on what data will ultimately be required by the accountable person throughout the golden thread. Now that we have an appreciation of what will be needed by the building safety manager to operate and maintain a building safety case, we can identify that what information will need to be captured through the design stage and the build stage. Gateway 1. At this early stage, the content that the accountable person will need during occupation and in what format that asset information model operates will be defined by setting the brief. Key to this will be what information in what format will be expected to be collected during concept, scheme and detailed design stages. A suitably competent team will need to be appointed to collect this data, and an equally competent team will need to sit client side to validate this collection. The major accident hazards that the building safety manager will be expected to control will need to be identified during a HAZ-ID. All this should happen pre-planning, before the design has progressed, so that the principles for data capture can be agreed and set in motion. Throughout all stages of the design, it's expected that the following will need to take place. Inputs into a separate BIM model will be generated and a dedicated platform created to capture data during the design. With the correct platform in place, this should be automated as the design is generated in BIM. This separate BIM model will be catered to align with the format of the asset information model being operated by the accountable person. Dedicated building information modeling managers will validate the content being generated to ensure it meets with the brief, much like an itemized list of deliverables you'd see in a request for proposal. It's expected that this role will sit client side and act much like a periodic peer reviewer. The design program will need to account for this review period at each client approval point. Much like the BIM manager, it's expected that a safety case author will need to be validating the data being captured during client approval periods. Again, if the brief is correctly set during planning, an itemized data list should be made available to the design team, which then can be validated by the client representative, such as the building safety manager or a building safety case author. Whilst the capture of data during a design is nothing new, the creation of a dedicated BIM model, which aligns with the asset information model, will be a new design discipline. Once the project design has been tendered and handed over to a contractor, the same principles of data collection will need to take place, but in a different manner. Much the same as during the design, input to the asset information model aligned BIM model will need to be continued throughout the build stage. The primary difference from the design stage, however, is the need to record installations on site and monitor what systems are actually being installed. It's expected that a dedicated clerk of works will be on site full-time to record and itemize the systems that will be operated and maintained in the building safety case. As with the design stage, the collection of this data by both the BIM manager and the clerk of works will need to be validated. Now, this can either be a continuous oversight for larger, more complicated buildings, or periodically for less challenging sites. And this role is expected to sit client side. So now we have come full circle. By determining what the end user needs, as in the accountable person and the safety case content, we can define what data needs to be captured through the design stage and through the build stage. So to summarize, the building safety case, or the golden thread, data will be migrated to the asset information model from the dedicated BIM model. By utilizing a digital golden thread, the building safety case will be able to be assessed continually throughout the life of the building as a live model. The regulator can request the latest up-to-date data whenever they choose and ratify the level of safety in the building. At Gateway 3, the client then hands over the golden thread to the accountable person. With this, the accountable person applies for the building assurance certificate, and their appointed building safety manager operates and maintains the building safety case. I highly doubt that the current procurement methods used for high-rise residential building projects will remain unchanged. The cultural change put forward by Dame Judith Hackett will no doubt see the inputs of the end user, the accountable person, at the very commencement of a development. Their obligations under the Building Safety Bill will push the accountable person to have a vested interest in ensuring that the data that they will be handed at the end of the build stage is accurate and contains the necessary detail to safely operate the building. So there we have it. The need to operate and maintain a building safety case will result in a new discipline for all high-rise residential projects. The information that needs to be collected during design, build and occupation needs to align with the asset information model utilised by the accountable person. The client will be responsible for capturing this data, and it's highly likely that the accountable person and their building safety manager will be involved in determining what data needs to be captured pre-planning, if not throughout. Hence the idea of cultural change. This is all new territory for the building industry. The expertise needed by a building safety case author during occupation or a clerk of works on site during the building stage are not the norm currently. So how can Hydrock help? Well, Hydrock's in a unique position to deliver on this cultural change. With our fire division comprising fire engineers and fire risk managers, we are well placed to appreciate the timely capture of data throughout the design and to validate installation throughout construction. With our safety case authors, we can advise what systems the building safety manager will need to be continually assessing. With our building information modelling managers, we can advise on the necessary platform the accountable person will need to maintain as an asset information model or a digital twin of their assets. Whilst not yet mandated, the digital capture will be delivered in BIM, and the use of such programs to capture data will be crucial to a successful building safety case. But what could come next? Will we see the adoption of the building safety case for more than just high-rise residential buildings? I'm sure the insurance industry will look very favourably on assets with such a complete data set and a functioning safety culture. Whilst these systems of safety management are adopted in one building, will they be adopted across an entire portfolio, even before mandated by the legislation? And now that these buildings will have data collated for fire and structural systems, the platform in place which aligns with the asset information model, it's not a huge leap to see this method used to collect data to enhance building performance. Our team of building physicists in the Building Performance Engineering Division actively collaborate with companies such as Siemens to collect data from the BMS, with which they can diagnose inefficiencies in a building use. Now that it's going to be legislated that building data is collected, why not include lighting, heating, cooling, humidity, air quality data as well? And with that final thought, I'll say thank you. And I want to give a few specific thanks as well. One for Mark Seabury for his ability to ask the right questions at the right time. Thank you to Graham Kelly for sharing all of his trade secrets. And also thank you, Rob Bracewell, for making complex ideas sound simple. I think we'll now have some time for questions.
Hi again. Thanks a lot. Can I cheers for that? Yeah, I've got a few questions for you. Is it okay if you mute as well, because I'm reverberating there. Cheers, thanks. So the first one we've got is from Samuel Preston from West Yorkshire Fire and Rescue Service. Will it be contractually possible for fire engineers to stay client and construction side, and will this create conflicts with regards to bias?
Yeah, thank you, Sam, for the question. That's a good point, whether we could sit client side or whether we could sit design side. I don't think anyone's sure just yet. Certainly, if you're asked to validate information for a client during a peer review, you can't be also generating that information or conducting that design. So I think there's going to be two separate roles. I do think there's going to be a dedicated role, which will be collecting data during the design and during construction. And then I think there will be a separate role to sit client side and validate what's being collected.
Excellent. I'll jump on to the next one, which is an anonymous one, unfortunately. Do you think it is possible to cost effectively implement the golden thread for smaller developers and contractors?
Yeah, I think everyone's going to have to appreciate there's going to be additional cost for the next couple of years as this system gets off the ground. But then my final point about insurance, I mean, I've discussed this with insurance providers, and they're all saying that you could feasibly see premiums reducing if you have this information available, and if you're promoting a high level of safety in your buildings, the risk of a hazard or a major accident hazard, is significantly reduced. So there may be some initial costs, but it may be weighed off later in the life of the building.
Ideal. And we've got another one from Andre. Will the fire safety bill affect the high-rise office/commercial buildings as well? And I've sort of tacked another one on the back of that, which is, what can you see the scope be going forward with the golden thread?
Yeah, thanks, Andrew. That's a good question, and I think everyone's saying the same thing. Everyone's talking about once this system's in place, and this cultural change of having a live system that can be continually updated, and the building regulator, building safety regulator, being able to come to your building and ask for a capture of that data straight away. You can see as soon as the system's up and running and that the expertise is available in the market, that it will be implemented by other building types. I mean, this is obviously coming about. This is reactive because of Grenfell. So they're talking about high-rise residential buildings and sleeping risk. So you can see it very easily extended to low-rise residential developments, but also as well, from a commercial point of view, you could see it extended to lots of other buildings. I mean, the building safety bill does apply to hospitals and care homes as well, but just not during occupation.
Excellent. And I'll do one more, so that should wrap everything up, I think. So I've sort of summarised this one. This one's from Simon Ince. So what advantage does the proposed safety case have over a fire safety audit, which is done annually by regulation just now? And how do you see the both of them working in conjunction?
Yeah, it's a very good question, Simon. I do think there will continue to be a risk assessment that will be carried out, and I think the risk assessment will probably follow a similar format than it currently does. But I think this idea of being able to quantify a level of safety is something that will be different. I think that's the way the two are quite distinct. The health and safety executive guidance are talking about how do you demonstrate a level of safety, whereas if you do a risk assessment, whenever I've done them and seen other ones done, have we got this system in place? Has it been tested and maintained? Yes, and then that's where you stop. Whereas if you're looking at quantifying a level of safety, you are going to be saying, right, we've got a sprinkler system in this building. How likely is that sprinkler system going to operate and control a fire as you expect it to? There's plenty of statistics around looking at case studies, but then you also have to delve into how regularly has the pump set been tested? Have they replaced the pump set? Has the tank been maintained recently? Is the secondary power supply a dedicated system? Is it off a utility connection, or is it split within the switch room? All these things will have an impact on your fault analysis. And this idea of a fault analysis, effectively, you put a branch of every occurrence within that safety system which could go wrong. And in doing so, you then apply a reliability factor to determine a resultant figure for this system is this reliable. And I think that's what will distinguish it from a risk assessment. I think you still need to do a risk assessment, as in go around and see what systems are in place. But then how you quantify that level of safety, I think, is the distinction we're talking about.
Excellent. So that's us sort of got to 10:45. So I'm just going to wrap it up there. There are a few more questions in there that we'll try and get a response out to. But I just basically like to say thanks a lot for Chris for enlightening us there. And yeah, thanks to all of you for coming along, and have a great day. Cheers.
Thank you very much, everyone.